Now, before we proceed with the core elements of the course, I would like to give you a brief overview of the 11-step guide. This is going to form the main core element of the course. It's the 11-step guide. Now, the 11-step guide is a method which we've developed to make the understanding of this potentially complex subject simpler. It's a method which, if followed, will cover the criteria you must establish prior to acceptance of any smoke management system. So what is the 11-step guide then? Well, this is the acronym. Orange Smarties make teenagers sing very nice songs publicly and privately. That's the acronym. So what are all the acronyms then? Well, O is design objectives. This is the first bit. In this step, you've got to determine what the design objectives are. Is it for property protection? Is it for life safety? Or is it possibly for access for firefighters? That's what you've got to determine first. S is your design fire size. In this step, you need to determine the fire size that you're going to adopt in all your calculations. And this is a critical stage, because if you get this wrong, the wrong design fire size means the whole system will fail. In this step, you might identify there's a number of different scenarios, and you might have to work out different fire sizes. You might have one that's a complex plume, one that's a simple plume. Yeah, so you might have different design fire sizes. That's what we're going to go through, how you work it out. M is your mass flow rate of smoke. In this step, you've got to determine the mass flow rate of smoke which is emanating from that design fire size. You might have a simple plume, you might have a complex plume. Simple plume, where the fire originates in the room where it's been extracted. A complex plume, like a shopping mall, is where it's got to travel down corridors before it reaches a spill edge. So that's your mass flow rate of smoke. The next step, temperature of smoke. In this step, you must determine the temperature of the smoke to ensure that it's not excessive, it does not exceed the design criteria. For example, if it exceeds 200 degrees C, it's not tenable. So if it's for life safety, the smoke can't exceed that temperature. If it's not for life safety, it doesn't matter so much. It's got to be at least over 20 degrees Kelvin, because if not, you're going to lose all the buoyancy. So in this step, we're going to work out how to determine the temperature of the smoke. Now, in buildings with high atriums, you have to consider the impact of the stratification, because in tall buildings, there may be a significant difference in temperature between the top and the bottom of the building. It's like similar to the staff key effect we mentioned earlier. V is your ventilation requirements. In this step, you're going to decide which method of extraction you're going to use, whether it's natural or mechanical, and then determine the mechanical or natural requirements. In this step, you'll need to work out the number of reservoirs, the ventilation area, or you've got your volumetric extraction rate. So understand natural and ventilation requirements, that's what we're going to work through. And you need to now know how many ventilators you're going to need in each reservoir, so that's that step. Stagnation check. In this step, you're going to ensure that stagnation will not occur. Smoke can't travel too far before it starts to lose its buoyancy. So in a natural ventilation system, you've got to carry out a stagnation check to make sure the ventilators are located a certain distance apart. P is your plug holing check. Now, the plug holing check must be carried out for both natural and mechanical extraction. And if it's exceeded, more smaller ventilators might be required. So you've got to carry out your plug holing check, and we'll tell you what you can do if it is likely to plug hole. A is your air inlet velocity. In this step, you must ensure that the air inlet velocity of the replacement air does not exceed certain limits. For example, for staff, it's 7 metres a second. For the general public, it's 5 metres a second. So we're going to go through how you ensure that the air inlet, when the air is coming in to replace the smoke, it's not going to cause problems with your means of escape. And finally, out of the 11-step guide is the post-design considerations. And in this final step, we're going to talk about issues such as the deflection of free hanging smoke curtains. We're going to look at the effects of wind on the system and things like testing and maintenance of your systems. That's in your post-design considerations. Now, this is the 11-step guide, which, if followed for all your system design checks, should ensure that you've considered the relevant areas to meet the design criteria.